Okay, these notes must be filled in before Friday or Monday, September 11th through 14th. You also need to read chapter 12, page 268 to 272 before that date. So this is an introductory activity that we would normally do in class, but I think it can be easily done or started at home. So what we're going to do is the sexual discrimination problem. I claimed recently a large company had to downsize and fire 10 employees. Of these 10 employees, 5 were women. However, only 10 of the 30 employees at the company were women. This discrepancy has led the women who were fired to file a sexual discrimination lawsuit. Do they have a legitimate claim? Well, let's think about that. It means only 33% of the employees were women, but of the people they fired, 50% were women. So it seems like they fired more women than men based off of the population. So we have to ask ourselves, what are the two options in this case? The first option is that the women have a legitimate claim. Okay? The company fired a higher proportion of women on purpose. Maybe they believe they aren't as productive. I don't know. The other option is they do not have a legitimate claim. Okay? This could have occurred by random chance. And so that's what we're going to test. Is it they just randomly put everybody's name in a hat, pulled it out, and said, okay, these 10 people got pulled out, you're fired. And it just happened to be that 50% of the people they pulled out were women. Okay? So we have to think, which of the two options can we actually assess? Well, we cannot assess the first one, that they have a legitimate claim. Okay, we don't know. Okay, we have no way of knowing what the boss was thinking. If he's actually chauvinistic, he doesn't like women, we don't know. But what we can do instead is we can estimate the probability of getting as a result as surprising as this by random chance. So it literally was just accidental, randomly happened that even though only a third of the population was female, they were able to pull out and fire 50%. Or that they ended up firing, of the people they fired, 50% were women. Okay, and so I put this one in red because this is what we will check all year. Is it as we want to estimate the probability of getting a result as surprising as this by random chance. So here's what you're going to do. If we were in class, I would have a jar full of beads, okay, representing the population of the company. So I would have 10 white beads for women and 20 black beads for men, okay, because they had 10 women out of 30 employees. And then I would have you randomly stick your hand in the bag and draw out 10 beads. Those first 10 are the ones that would get fired. And then you would count how many of those were white. So you're going to do the same thing at home. Okay, if you have some type of beads or marbles, you could do that. Or you could use pennies and dimes. The problem with pennies and dimes is that they don't feel exactly the same, so it's a little bias. Or you could use 30 pennies and take a black marker, and that's what I would do, and color on 20 of them to make that the men, or put an M on 20 of them, something like that. Okay, but you will have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 men in your pool. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 women in your bag or whatever you're doing. And then I want you to draw out 10 of them. Okay, so stick your hand in there and draw out 10. If worse comes to worse, take little pieces of paper, all the same size, circles or squares, and color. Okay, color them in. I want to know what you did. So if you use papers, bring them to class. If you use pennies, bring a few of those to class. Okay, let me know how you did this. And then maybe you do it and you get 4 women and 6 men. Okay, bring that to class, and we will finish this next time. All right, let's go down to some definitions. Okay, well, and let's go down to some definitions. Definition. Statistics is the science of collecting, analyzing, and drawing conclusions from data. Okay, so that's what we'll start really doing, not just collecting data and making stats, mean, median, mode. We're going to use that to make conclusions. Okay, the population of interest is the entire collection of individuals or objects about which information is desired. So if I wanted to know the GPA of all Hillcrest students, that's the population of interest, even if I only take a sample and get GPAs from my students. Okay, when you study an entire population, it is called a census. So if I used Skyward and I got every GPA for every student and then took the average of that, that would be a census. Okay, but a sample is a subset of the population, selected for study in some prescribed manner. So instead of having to get a hold of the office and get everybody's information, I decide just to look up my students' GPAs because that's easy for me. That would be a sample. Okay, the next one. A sampling frame is a list of individuals from which the sample is drawn. So maybe instead of just using my students, I have the office give me a list of students, and I go through and pick every 5th one or every 20th one from alphabetical order and make that my sample. Okay, that is the sampling frame. The next definition is a parameter, and it's a characteristic of an entire population, okay, such as the average height of all Hillcrest students, or the proportion of all U.S. citizens who approve of Barack Obama. Unfortunately, we cannot know the value of a parameter without taking a census, okay? Notice the key word here is all and all. So I cannot know the average GPA of every single Hillcrest student without taking a census, actually getting all of that data. All right. Last but not least, the last definition. A statistic is an estimate parameter based on a sample from the population. For example, based on a sample of 50 Hillcrest students, we estimate that the true average height is 67.1 inches. So maybe I just went in the lunchroom and randomly said, hey you, how tall are you? Hey you, how tall are you? And I did that for 50 students and then took the average and said, you know, I think that's probably what it's going to be for all the students if we did all the students at Hillcrest. One application of statistics is to determine the readability of various books and articles. One simple way to do this is to estimate the average word length. So we're going to consider the Gettysburg Address by Abraham Lincoln, one of the most famous speeches of all time, okay? And I've gone ahead and given that to you here. And what you're going to do is you are going to randomly, or words of your choice, okay, you just pick 5 words. So let's say I looked at it and I said, hey, I like the word struggled. So I pick it and then I count 1, 2, 3, 4, 5, 6, 7, 8, 9. Struggled has 9 words or 9 letters. Okay, and then I'm going to look through it. I'm like, hey, I like the word we. We has 2. Brave. Brave has 1, 2, 3, 4, 5. Maybe I'll do continent. 1, 2, 3, 4, 5, 6, 7, 8, 9 again. And so that's 4 words. I need one more word. Gave. Okay, 4 letters. So then I'm going to take the average. So let's see. 9 plus 9 is 18. Plus 2 is 20. Plus 5 is 25. Plus another 4 is 29. I divide that by 5. Okay, so 29 divided by 5 is an average word length based on my sample of size 5 of 5.8. And again, if we want to look at it, that means my n was 5 because that was my sample. The formula for average is the sum of all the numbers divided by n, which was 5.8. And you need to do that and have it all written down before you come to class next time. Have a good night and go to the burning of the H.